everyone. Uh, Assalamu alaikum. My name is Muhammad Hamid Nawaz. These are my group members Hamid Nawaz, Hashim Skandar, Daud Munir, Ali Hassan, and Burhanuddin Khan. Our topic is survey of memory management techniques for HPC and cloud computing. First of all, we will discuss the introduction of our topic. Uh, what is memory management? Memory management is the process of controlling and coordinating computer memory, assigning portions called blocks to various running programs to optimize overall system performance. Memory management resides in the hardware, in the operating system, and in programs and applications. Now we will discuss the techniques of memory management. There are several techniques of memory management, but we will discuss some of them techniques. First of all, we will discuss ESX by VMware. Actually, it allows the virtual machines to use more memory than the physical machines' available memory. In ESX, the memory management techniques allows the virtual machines to use more memory than the physical machines' available memory. For example, you can have a host with 2 GB memory and run 4 virtual machines with 1 GB memory each. In that case, the memory is overcommitted. To improve memory utilization, ESX transfers memory from ideal virtual machines to virtual machines that need more memory. Now, transparent page sharing TPS. Actually, it is a memory management technology in virtualization that condenses redundant memory pages on a host into one page. Actually, when multiple VMs are running, some of them may have identical sets of memory content. Several VMs may be running the same operating system applications, and same user data. With page sharing, the hypervision can reclaim the redundant copies and only keep one copy, which is shared by multiple virtual machines in the host physical memory. For example, GitHub. Now we will discuss the third technique of memory management, which is ballooning. Actually, it is a management feature used in most visualization platforms, which allow the host system to artificially enlarge its pool of memory by taking advantage or reclaiming unused memory previously allocated to various virtual machines. Uh, Actually, it is a driver used to communicate with applications to understand their memory needs to make room for others. Now we will discuss the 4 levels of virtual system management. There are there are 4 levels of virtual system management: swap manager, memory watchdog, data importer, and data exporter. First, we will discuss the swap manager. Actually, it keeps record of all the resources using the memory. In this, it is a commuter technology that enables an operating system to provide more memory to a running application or process than is available in RAM. When the physical system memory is exhausted, the OS can opt to make use of memory swapping techniques to get additional memory. Now, memory watchdog, it alerts the host about the memory leakage and out of space problems. Actually, in memory watchdog, it is an algorithmic feature for APM performances and infrastructure metrics that automatically detects potential application and infrastructure issues. Third level is data importer. Uh, Data importer is the communication channel to import data, which also maintains logs. Fourth level is data exporter. In data exporter, the communication channel to export data, which also maintain logs. Now we will discuss the DRAM and SPRM. Actually, DRAM is a type of semiconductor memory that is typically used for the data of program code needed by a computer processor to function. DRAMs are charge-based devices where each bit is represented by an electrical charge stored in a very small capacitor. The charge can leak away in a short amount of time, so the system has to be refreshed to prevent data from being lost. It also offers the best price per performance as well as the higher density of memory cells per chip. Now the static random access memory S- SRAM, actually it is a random access memory RAM that retains data bits in its memory as long as power is being supplied. Unlike dynamic RAM DRAM, which stores bits in cells consisting of a capacitor and a transistor. SRAM does not have to be periodically refreshed. It actually is based on gates and each bit is stored in 4 to 6 connected transistors. They can retain their data as long as they have power without the need for any form of data refresh. It has it has access times down to about 7 ns at higher cost, heat power, and board space. Now I will call Hashim Sikandar to discuss further.
Yes. Uh, my topic will be difference between high performance computing and cloud computing. First, we will discuss how HPC works. How HPC works. Uh, in further, we will discuss the capability of HPC. High performance computing, as name, is much like a regular computing, but considerably more powerful. If you have ever heard the term supercomputer, it is what it meant. To give you a more sense of perspective, a typical home computer might be capable of around 3 billion calculations per second. On the other hand, HPC solution will be capable of quadrillions of calculation per second. Next point will be parallel processing. High performance computing can be achieved through parallel processing, where multiple nodes, sometimes thousands, work in a tandem of complete tasks. These typically involve the analyzing and manipulating data. What is the downside of high performance computing? The downside of high performance computing is that they are often prohibitively very costly. They are made up of best processors available, rapid memory, specially designed components, and uh, elaborate cooling mechanism. Plus, it isn't easy to scale a supercomputer. Once the machine is built, this becomes a project to load in additional processor. The next point will be processor pro. Jani, जरा रोक start. Processor proliferation. Processor proliferation. A computer consists of processor and memory. Essentially, the processor conducts the work and memory holds information. When the work you need to conduct is relatively basic, you only use you only need one processor. But if you have many different variables and large data sets, though you sometimes use additional processor. Many applications in public and private sector require massive computational resources. Explain Center for Data Innovation Research analyst Travis Scott, such as real-time weather forecasting, aerospace and biomedical engineering, nuclear fusion reactions, and nuclear stockpile management. Now we will further discuss about how cloud computing works. For those, cloud computing covers a high brand range of tasks from high level to low level memory. जानी जरा recording को stop. Now we will discuss about how cloud computing works. To carry out on other standards of home computers. Next, as the form of distributed computing, a task overflow discuss the difference between cloud computing and distributive computing. What defines cloud computing is that the uh, the underlying computer resources of cloud-based services and softwares are entirely abstracted from consumers of software services commitment elite users. Nathan, this means this means that the vendor of cloud-based resources is taking responsibility for the performance, reliability, scalability of computer computing environment. In other words, it is easier since you don't have to handle and maintain sport. Now we will discuss the cloud that meet expectations. Cloud is essentially democratizing high performance computing. That's a good news for anyone who previously don't have access with the supercomputers. Before you work with a cloud provider, though, you should know that many don't actually have a distributive architecture. Instead, they are mainframe era centralized storage and Ethernet networking technology. This result is that they cannot achieve 200% high availability. Now we will discuss which one is better among them. First, we should have to understand that cloud computing and high performance computing are not same things. They are not really same things. As such, pitting them against each other is sometimes a fluid task. The answer to which is better depends on the situation and a user individual needs. For vast amount of data crunching, high performance computing will always outperform cloud computing. They can broadly be classed as similar systems, but the connections between each nodes of a cloud computing is simply too slow to compute with high computing high powered computing speeds. If the task is within the scope of regular computing, a high performance computing solution would be vastly more powerful and expensive than necessary than compared to cloud based solution. As with many things in life, the best solution is the one that fits your specific needs. For those, if those needs change, the solution may well change too. Next will be uh, the affordability of cloud. In constant, one reason that people choose distributed computing of cloud is that it is much more affordable. The design of the distributed network may be incredibly elaborate, but hardware components and cooling is not needed to the high end and specially designed. It scales seamlessly. Processing power grows as additional serves with their processors are added to the network. Cost difference for tasks. The choosing between cloud computing and HPC computing depends on the task and cost. If you are running an organization or a big company, then you should use high performance computing as it can perform tasks for the whole company and can be used by many employees at a time. If you use cloud computing in this situation, it will cost you too much as for all employees. But if you need a personal computer, the cloud computing will be the best and efficient option. Here I will give you an example of Wall Street supercomputer. Supercomputer. As Wall Street needs too many employees and they all need a stock difference and charts. So they at a time they all use a single supercomputer, which definitely defines that if you have a big organization, then high performance computing will be efficient. And the next part will be discussed by Daud Munir.
Today, I'm going to discuss the efficient memory management system. First, we are going to define what is memory management. Memory management is to optimize memory management algorithms to store and handle data, which is one of the main topics of these days, and why it is needed. These days, obsolete software such as IaaS is in need of smart memory management protocols in to be integrated in cloud in order to get rid of latency and load balancing issues. And the issues of we are gonna discuss the importance of efficient memory management. First of all, sharing memory. Shared memory is the technology that enables us for computer programs to simultaneously share memory resources for higher performance and fewer redundant data copies. Then memory reclamation. This is to help decrease the use of allocated memory before the task has been performed. Next, memory virtualization. It decouples the volatile random access memory, which is RAM, resources from individual systems in the data center and then aggregates those resources into a virtualized memory pool available to any computer in the cluster. Several VMs may be running instances of the same guest OS, have the same application or components loaded, or may contain common data. The hypervisor exploits these sharing opportunities so that server workload running in VMs on a single machine often consume less memory than they would be running on separate physical machines. Then page replacement. Transparent page sharing as a method of eliminating redundant copies of pages such as code or read-only data. Across virtual machines, once copies are identified, multiple guest physical pages are mapped to the same machine page and also marked copy on write. Writing to a shared page causes a fault that generates a private copy. Then demand paging. In proportional share frameworks, resource rights are encapsulated by shares. Software layer that virtualizes hardware resources, exporting a virtual hardware interface that reflects the underlying machine architecture. And fault containment of
One kindly share this slide. So my name is Arisa Ferguson. Today I'm going to present on memory management technique in HPC and memory management technique in cloud computing. Let's start with HPC. First of all, we will discuss dynamic memory. In dynamic memory allocation is commonly used with traditional HPC system that is usually performed by the system OS based application. Does not require changes, but heterogeneous applications are required to declare memory needs before offloading a computation. Now further I will discuss about surveyed memory architectures. Basically, surveyed memory architecture objectives and hardware software technologies that are depending on target architecture. The brief introduction of memory architecture is present in memory architecture figure. As you can see, the figure architecture And now the further I'm going to discuss about access pattern. There are three types of access patterns. The number one is pattern aware memory system. Second is sharing aware memory management units. Number third, pattern aware memory controller. First, I will discuss about pattern aware memory system. According to access pattern regarding the limitation of data, read and write latency for ERAM integrated to same silicon with the logic AM for hiding all the communication between the local memory. The local memory management system called pattern aware memory system operates independently from the cores. It accelerates both static and dynamic structures and their patterns. Now discuss about the sharing aware memory management unit. It has analyzed with memory access behavior on the hardware level. It also provide information to the system to perform an online thread and data mapping to increase the locality regarding improving performance. Uh, Next one is pattern aware memory controller. In pattern aware memory controller assess pattern which is based on execution and architecture in application. Application is basically a processing unit that passes the flow with the connection in memory allocation. PAMC is basically in charge to optimize memory allocation and can be considered on the levels of memory hierarchy. Now we're going to discuss what is memory locality. The memory management is done as a separate service as a part of runtime management system on service node. It controls all location on node. It deals with some following issues like there are three main issues that is choosing main suitable memory, enabling concurrent runtime optimization. First of all, I'm going to discuss about choosing main suitable memory. In choosing main suitable memory, memory is selecting the best modules. The memory manager takes into account in this part. We have further classification of suitable memory. There are basically five further classifications. Number one is bandwidth, latency of memory module, direction of data transfer, space available, land or routing and ports. So second problem is that enabling concurrent. There are some implementation that are concurrently function. Each one has its own strength or weakness. Memory cloud is basically managed on OS. In HPC, controlled memory can be taken by OS or by dependent library. Now the last one is runtime optimization. This is free memory. The memory is evaluating the possibility to migrate the data of running into suitable memory. It allows the memory allocator to perform the running kernels and free for higher priority applications. The benefit of migration evaluated for users, the kernel that must be stored while data is moved. Kindly move next slide. So the next slide is memory management in cloud computing. So in this slide, I'm going to discuss about memory management in cloud computing. The first of all, the, the first we discuss about scheduling. Generally, scheduling may be decision-making process that allows to distribute available resource among variety of tasks by determining the order of execution. Scheduling is a problem. Moreover, scheduling in cloud computing architecture may be a bit more complicated to heterogeneity of virtual machines and negative impact of transfer to a large data between VMs. Recent studies on scheduling within the cloud were analyzed from the memory management techniques point of view. In data distribution and the task distribution are defined as dependent problems, and that they are analyzed together for efficiency scheduling. Data communication requires between virtual machine and storage nodes. It is additionally to computing and memory resource demands are taken under consideration within the scheduling approach. Layers of the info communication requirement, scheduling in the intermediate task and intermediate data within the system with four-level cache memory hierarchies introduced in aim to optimize performance and energy consumption. The scheduling approach uses profiles which are created on the machine learning information alongside resources that were used during execution, like CPU, memory, several computer nodes, input data size. Virtual resources scheduling techniques use an energy consumption model to perform VM migration from the overload host. Basically, there are two types. Resource cost model includes two parts of the CPU, memory and cost. First I'm going to discuss about memory. The memory, such as the base cost and therefore the cost related to transmission of memory, The purpose approach achieves the optimization for the optimal span, deadline, resource utilization, and user cost. Now the further is cost. This work focuses on two sort of resources: CPU, disk input output bandwidth, but the approach allows to scale the number of resources. Now further, I'm going to tell about the resource and user allocation. The complexity of provisioning algorithm for homogeneous resource allocation is already high, and therefore the computation time is long. Further considerations on deeply heterogeneous resources add additional dimensions to the computation, which can significantly increase the complexity. The stage of resource allocation is liable for allocating VM to the host, represented as three-dimensional qubit with CPU, network bandwidth, and memory capacity of the host and axis. Now, further, I'm going to discuss about memory aggregation and disaggregation. Modern system architectures aim to enhance resource isolation approach, allowing servers to share their resources through the memory hierarchy, and execution for the hypervisor to share the memory capacity of the nodes across the computing infrastructure called globally visible team was proposed in a software architecture allowed to aggregate memory across nodes using Zen transcendent memory. Now, further, I'm going to discuss about memory pages management. In a virtualized system, during the VM boot, the boot manager initializes a guest VM memory and add the VM pages under the control of OS allocator. Often, a situation arises when the one virtual machine has free memory, while other virtual machines don't have enough memory. The workload of several VM applications changes over time, so memory requirement may suddenly decrease or increase dramatically. However, Albert hypervisors have an outside number of free memory pages. They cannot reallocate memory to a guest who needs urgent memory to use. When the memory requirements are but the quantity of the free memory, the guest will necessarily start the guest paging mechanism, will cause a decrease in performance. An imbalance in memory use cause a wastage of resources. Hypersupervisor typically already support and dynamic allocation of processor pool between different VM. Balloon driven may be widely used approach to enable memory resource overcommitment. However, the ballooning driven does not move memory fast enough to satisfy the memory management. Since virtual machine memory swapping might be triggered while the balloon drive is moving the memory across guest VM. Another challenge is that the double paging problem, which is caused by the inefficient swapping activities between the guest operating system and therefore the host operating system. The, the necessary disk input output caused by the double paging problem could, could seriously affect the performance of guest virtual machines. Now further, I'm going to discuss about the shared memory. Recent development has been dedicated to improve communication efficiency between VMs using the shared memory channels. Shared memory is employed in cloud solution to scale back the overhead of knowledge across and to extend resource sharing between different VMs or different VMs and a number. Several techniques are proposed that differ in terms of where and the way a shared memory channel is established. Host allocated dynamic shared memory. The dynamically managed shared memory regions allow each virtual machine to assess the shared memory supported its workload requirements. Now, kindly move to next slide. Now I'm going to tell the difference in both memory management in cloud computing and memory management in HPC techniques. First of all, I will tell you about HPC techniques. OS-based memory management is a technology in which many modern HPC systems is included. It offers better functionalities. It provides areas of use for application developers. HPC allows some sufficient performance in HPC system and requires less system effort to adjust various runtime management systems. There is a trend to complicate the architecture in HPC system, which require more OS functionalities. Now, further, I'm going to tell about the memory management techniques in cloud computing. The number one is the growth of scientific workflows and of the data set and the complexity of computational multi-parametric models is pushing us to use the cloud solutions. This need memory management adoption for the efficient use of novel workload characteristics and resources. In contrast to the normal HPC architectures, the most resources provided by cloud and VM and storage areas. To perform an HPC application within the cloud, the execution of every task has got to be scheduled to an appropriate virtual machine. Now, the further slide will be discussed by Bruhan.
Assalamu alaikum. As you know, hope you are all fine. As my group members highlighted the basic concept of memory management. Now I am Mohammad Burhanuddin Khan, presenting before you the major issues regarding memory management. First of all, I am not talking more than other members telling about what is the memory management and what is issues. What is I am not telling about issues. This is the major problem of uh, our research paper. I will tell little bit about HPC issues. Firstly, the main issue of porting HPC application to the cloud environment depends on the difference between the requirements and workflow of the traditional cloud services application and those of HPC application. HPC applications tend to require a high amount of cloud resources such as CPU, memory, and bandwidth. Regarding the differences in the workflow, HPC applications are often executed in batches. Like this is a major issues we are searching the data environment issues, workflow of cloud is main issues. Now we are little bit telling about these issues that is, you can see that these are the some several issues as well regarding performance issues, security issues, and memory management issues. My first point is performance issues. You can see that this is performance issues points. Now I'm not telling more about these issues because this is some performance issues, not from my research papers. Uh, and this is a little bit about performance. The most well-known performance issues you can see that memory management issues, data quality and mobility and data storage and security vulnerability issues. Now I am telling about security issues. This is the second slide of my topic. You can see that this is the some issues of security. This is like environment, input and output, usage and standards and processes and policies and trends and risks. This is the issues of security that is coming in HPC cloud environment. So I am telling about major issue. This is the major issue of memory management issues. I am more explained in this issue because this is major issue for our research paper. So from this is the first point of my major issue of memory management. My first point is premature freeze and dangling pointers. You can see that many programs give up on memory but attempt to access it later and crash or behave randomly. The condition is known as premature free and the surviving reference to the memory is known as dangling pointer. This is usually confined to manual memory management. Now my second point is memory leak. Uh, because this is the main issue of memory management. You can see that this issue of memory. This is the major issue of your data is losing behind, or you cannot know what is happening. So because memory is a program continuously allocate memory without ever giving it up and eventually run out of memory. This condition is known as memory leak. Now I'm telling about third point. This is external fragmentation. A poor allocator can do its job of giving out and receiving blocks of memory so badly that it can no longer give out big enough blocks despite having enough spare memory. This is because the free memory can become split into many blocking. Small blocks, yeah, blocking separate by blocks still in use. This condition is known as external fragmentation. Now my next point is poor locality of reference. Another problem with the layout of allocated blocks comes from the way that modern hardware and operating system memory managers uh, handle memory as successive memory accesses are faster if they are too nearby memory locations. If the memory management places part the blocks or program will use together. This will cause performance problems. This condition is known as poor locality of reference. Now my fourth point is fourth note fifth point is inflexible design. Uh, in inflexible design, memory managers uh, can uh, can also cause severe performance problems if they have been designed with one use in mind, but are used in different ways. These problems occur because any memory manager solution tends to make assumptions about the way in which the program is going to use memory, such as typical block sizes, reference patterns, or lifetimes of objects. If these assumptions are wrong, then the memory managers may spend a lot of time doing bookkeeping work to keep up with what's happening. Uh, this is not now what is happening in memory. This is the more inflexible design. If you are not know what has happened in designing, so this is the main issue. Now I am telling about 6 point. This is interface flexibility. If objects are passed between modules, then the interface with design must consider the management of their memory. A well-designed memory manager can make it easier to write debugging tools because much of the code can be shared. Such tools could display objects, navigate links, validate objects, or detect abnormal accumulations of certain object types or block sizes. This is the major issues that that I was telling in this presentation. So now I am going to tell about what is the references of our this presentation of a whole project. This is the references. This is the references that I am. You can see that this is the references, and now we will over this the end of our presentation. Thank you both of all and all members. Thank you for this presentation and take time for this and come for this time. And thanks to all of you. Allah Hafiz.